Soln did was looking at a chemical reaction and trying to predict something about how we would observe or measure aspects of it. And so we started with the silver bromide, which is straightforward and easy because it's a solid. Solids are easy to measure because you would just weigh them on a balance. Okay? The rest of the substances up here are going to be a lot more problematic. And they are problematic because they are aqueous. And the problem with the aqueous phase is that it's not really a proper phase. It's a mixture of phases. And that mixture makes it more difficult to observe and monitor and calculate how much stuff is actually there. Okay? So when we look at mixtures in other locations, you've probably already heard of different references in, say, your everyday experience. Of course, the only thing coming to mind right now would be ABV. Like, I have no idea what ABV is. People above 21 might have a better understanding of what ABV is, at least officially. Alcohol by volume. Right? So most alcoholic beverages have what is known as an ABV associated with them. So you get a certain percentage. So it's the percent of the alcohol per what? The volume of the entire solution or the entire container. When we go through to do, for those people on Tuesday, the copper ore lab, you also did a percent there. You did a percent of the copper ore or the copper in the ore sample. Okay? You're effectively measuring a concentration. For solids, we don't need concentrations as much because we could just separate the solids away from each other. With solutions, that becomes challenging. How do I separate away silver nitrate from the water that's dissolved in it? Well, I could completely remove the water, and I'd be left with the silver nitrate, right? But I'm not reacting silver nitrate solid. I'm reacting silver nitrate in water. So if I wanted to know how much silver nitrate was there, and my procedure was evaporate all the water away, figure out how much aluminum or silver nitrate there was, and then put all the water back in, that's kind of tedious. So when we go to the shelf to pull the chemical off the shelf, it's usually in a solution, and we want to know that concentration. Okay? Kind of like when you're 21, when you pull something off the shelf that you were going to drink, you kind of want to know the alcohol volume, okay? Because it should drastically change how you interact with that substance. Okay? So, how do we do it in chemistry? Well, we don't go by volumes. Okay? Why not go by volumes? There's a couple threes up in our equation, right? 3 what? Molecules or moles. They wouldn't be atoms because these are more than one element there. Okay, so 3 molecules or 3 moles.
So if it was one element, it could be an atom?
Then we could call it an atom. Yep. Based off of molecules or moles, which one is more useful for us? Moles. A single molecule is too small to measure, so we go to moles. Okay? So if I'm going to look at a concentration, what units do I want in that concentration? For sure, it needs to take into consideration the total volume of the sample. Okay? Why? How are we going to measure that liquid solution? Milliliters. So I need to know that volume because that's going to allow me to do a relationship with it. Okay? So the total volume has to be factored into this system somehow. Okay? And what I'm concerned about is how much of the active species, if we're looking at silver nitrate, how much of the silver nitrate is in that solution or in that volume? What unit do I want for that measurement? Molarity is what we're trying to create. So the question still comes, what do we want to use for that unit? Because if I'm going to look up the concentration for, say, the silver nitrate, I can decide whatever concentration I want. This could be by volume. okay? Like alcohol. Milliliters over liters. So the milliliters of silver nitrate over liters of the solution. That's a valid concentration. Is that one that would be useful for us? Well, what is the phase of silver nitrate? It's a solid. So is milliliters of silver nitrate going to be useful? No. I know we need the total liters of solution, so that's got to stay on the bottom. What we're asking is what should that unit that I'll now color in blue be? Milliliters doesn't fly. Moles per liter, or another suggestion, grams per liter. So we get two possibilities that we could use. We could use grams of silver nitrate per liter of solution, or we could use, I already forgot, moles of silver nitrate per solution, liter of solution. Both of these are valid conversions. Both of them have the potential to work for us. Okay? Grams is likely the most useful one if I want to make the solution, because to make the solution, I'm going to need to measure out the grams of silver nitrate to add into this. Okay? But as a chemist, what is our role? Just to make solutions?
How much in there?
Okay. Making the solution grams still satisfies that. Chemistry started with what? Lead into gold. The whole point of chemistry is to convert one thing into another. That's chemistry. Where do we find the information to convert one thing into another? Periodic table does not convert one thing into another. All that does is allow you to look at a single substance. A chemical equation shows you how to convert one substance into another. Well, what units are in the chemical equation?
With what you have.
Number of molecules.
The number of molecules, atoms. Those are really, really, really small. I'm not going to be able to measure those.
If you use moles, it's easy to convert it.
If I use moles, the chemical equation can now make sense. So the chemical equation does not relate the mass of one substance to the mass of another substance. It relates the number of particles across. That would be our molecules or atoms. Molecules and atoms aren't a useful unit because they're too small for us to be able to manipulate. So we artificially scaled it up to moles, a very large number of them. So the chemical equation gives me moles. That's how I do a conversion. Things to things. Okay? Back to my concentration. Which unit is going to be more valuable to me if I'm a chemist where my job is to convert one thing to another? Moles ends up being the more useful conversion. Okay? What if my job is to ensure that there's a proper amount of salt on the road so that the ice melts? I just need to know the mass of salt that I have to add to the road. Okay? So in that case, that person is not acting as a chemist. They're not trying to convert one thing to another. They're adding salt to melt the ice. Okay? It's an entirely different process. In that different process, do they care about a conversion? No. So they don't care about using a chemical equation, which means they don't care about moles, which means instead they care about grams. But let's push this a step further. If you're that person trying to melt ice on the road, are you going to be using grams of salt? No, you're going to be using arguably tons, but yes, kilograms of salt, a much larger unit of salt, because you have to add a lot of salt because of all of the ice you're working with. What does that mean for us? That means depending on the environment, you can see different units for concentration. Okay? And the jackhole that came up with naming these two units, I have no idea why they did it, but they did. Kilograms per liter or moles per liter. The moles per liter is our chemist unit, so that one should be the bigger one. Okay, that moles per liter we call molarity. Kilograms per liter, not a chemist usage. Chemists will co-opt that terminology and use it in their classes because it's now a relatable system. It's not really a relatable system because you aren't using kilograms per liter to convert substances. You're using chemistry to take advantage of something else. Okay? What is the unit for kilograms per liter? What is that one called? Just curious if everybody knows it. It's not in the book. Okay? Moles per liter was molarity. Kilograms per liter is molality. Molality. I don't know the logic behind the name switch there, but I do know for a fact that some of the names associated with conversion factors are selected because the people thought it was an important thing to point out and a name was already associated with a different thing that was similar to it, and they didn't want people to forget it. So they intentionally made a name that was similar to the one that was more popularly used so that everybody would see them as equally important.
Supergirl and Captain Marvel.
Okay? Sure, Supergirl and Captain Marvel. The big one that I know of, enthalpy and entropy. Entropy as a name was literally determined because it was similar to the word enthalpy. That's why they picked it. Okay? I wouldn't be surprised if something similar is happening here. Okay? So be aware of that. You can see molality, particularly if you're going to move into, say, 151, into some full-on general chemistry stuff. They definitely talk about molality. For our sake, molarity is where it's at because we're talking about chemistry and trying to convert those substances. Make sense? So, we advance it out. We get our molarity, which is moles per liter. Okay, moles of one substance per liters of the total solution. Okay, that's a pretty complex unit, right? I'd have to write a lot of stuff down. That's a lot of work. So what do? I abbreviate it. And instead of writing it as moles per liter, I write it as capital M. That capital M abbreviates the amount of stuff that you would have to write on a label, and that's fantastic. However, capital M now confuses you who have to do a conversion. So your very first step when you see a capital M is to do that language conversion. What do I mean? I have a solution that is 3.6 capital M in silver nitrate. Okay. That notation means I have a solution that is 3.6 molar silver nitrate, which should be extra confusing because we had molar mass, right? And now we're just saying molar. Okay. That capital M means what? 3.6 moles per liter. So the instant you see 3.6 capital M, you should not write capital M. What do you need to write? 3.6 moles, okay, over liters. Right? You should be screaming no, because we talked about this.
No.
Okay? There's multiple things wrong with what's in blue. Okay? And he just pointed, there's no substance. The substance is pretty freaking important. Okay? That should be in there. What else is the problem with this?
You changed molarity into moles. You wrote the number first.
I wrote the number for, I think I see where you're going with that. Not bad, no. Or there's three things now. Write a numerator and a denominator. Do whatever you got to do. Give me a fraction in your notes. And yep, I'm looking at your notes. If you don't give me that, I'll just subtract points from the exam. which doesn't mean I'm taking points away from your possible. I'm just saying instead of it being out of 110 points possible, I'll make it out of 108. So you only get 8 possible extra credit. So write a fraction. We're not asking for a lot, just a fraction. Any fraction you want. Write the fraction that you want for a grade in this class. Thank you, Kendall. That shouldn't be your grade in the class, for the record. Did you write that after I told you to write a fraction or before?
This one?
Yeah. Okay. Very good. What do we got for a fraction? That looks like a fraction. That looks like a fraction. That looks like a fraction. Okay, this is interesting. As I walk around and look at what everybody has written for a fraction, not a single person provided this as a fraction. Wrote it this way. I want the fraction 1/2. What should I write?
1/2.
Fantastic. That's exactly what you guys wrote. What did you not write?
What it is.
Remember our conversation about that difference? The slash is a typewriter artifact. You are not a typewriter. Don't write it like a typewriter. That is a bad habit to get in the process of. Okay? So that's the biggest mistake I see within that. Okay, yes, the substance is a huge aspect behind this. So when you're going to convert 3.6 molar silver nitrate into 3.6 moles in liters, show it as a proper fraction. Okay? So what other things do we want to add in here? There's a suggestion that we want to throw a 1 in there. Is it strictly necessary to throw the 1 in there? It wasn't specified before, okay, so it's not critical to add it. Why would I recommend you add it? If you don't put a number there, what do you start to do? You put a different number in there from somewhere else in the question. If you place that 1, you've now locked that position that you don't start combining pieces of information. Make sense? Okay, so that's useful. Andy had a good point. Moles of what? Silver nitrate. Liters of what? Liters of water? How much silver nitrate would be found in water?
Well, that's the solution. Oh, silver nitrate aqueous.
So let's be careful with our terminology here. That's the solution. Is the solution water?
Not anymore.
No. A solution is a mixture of multiple things. Water is just water. Right? So if I was to write just water under there, there is no silver nitrate in water. There is silver nitrate in a solution of silver nitrate. Does that make sense? So we're looking at very subtle changes in turns of phrase behind the language because we need to understand the language before we can start to manipulate things. Why was the 3.6 written with moles and not with liters?
Not a void.
It's because moles over liters.
This one is tricky. I would go back to our statement. 3.6 is close to what letter? M. M begins with, not the right word. Which of our units begins with M? Moles, which means our number should be placed next to the moles. Okay? Does that mean you will always write moles over liters? No. You will write moles over liters when you want to do what with the molarity? That's hard. When I want to multiply by the molarity. You won't write moles over liters when you want to divide, because when you divide, it's going to flip the units. Okay? Kind of makes sense? What we're trying to establish is just what is the relationship between those? Okay? Where do they divide? Where's that line? So far, so good? Okay. What is the molarity of a solution containing 24.0 grams of sodium hydroxide and 0.1 liters of solution. Okay. This is the exact same process that we've been doing. All we've done is introduced a new conversion factor, which ultimately shouldn't matter. Set up your work, try and solve this. So we're going to go ahead and start with this. What were you asked to solve for? You were asked to solve for the molarity of solution. One person actually responded to that question correctly when I just asked. Okay? Most people went through and said molarity of the solution. Molarity of the solution is technically wrong, according to how we just talked about it. Okay, why? Because what is the symbol for molarity of the solution? Capital M. Capital M is a useless unit. It doesn't show up anywhere. It was an abbreviation of a proper unit. Okay? So you should not be solving for capital M. You should be solving for moles over liter. Awesome first step. Moles of what? Sodium hydroxide. Liters of what? Of the solution. Putting those proper pieces of information down allows you to frame your entire solve. If you do not do that, you're relying on your blind luck to mash numbers together. That's fine. Okay? Or you're relying on the fact that you've memorized an equation. You will run out of memorization ability eventually. And it may not even be in this class, but you will find it. And if you rely on only memorization to get you through, particularly academia, you will hit a wall. And usually what happens when you hit that wall, if you haven't learned how to work around that, is you will fail out of school. I've seen it lots of times. It sucks. Okay? So you need to learn sooner rather than later how to get around problems in the road, around natural talent. Okay? So we have moles of sodium hydroxide and liters of solution. I'm going to throw in an extra little piece here. I'm going to say that I should actually do this and moles sodium hydroxide, liters, and solution. What change did I make? Changed all of the colors. Why? To separate all the pieces of information so you can see where those things are. So that when you start bringing information in to solve this on the left-hand side of that equals, you know why you're doing it. Okay? So let's go through. Ideally, what do we see in our question? The ideal world, what would I see in the question? What would I find up there? I think someone said it. Ideally, what I see up there is moles of sodium hydroxide in liters of solution, because then what would I do? Just put those two numbers over each other and I'm done. Ta-da! Do I have that? No. Okay? So I'm going to have to do some work. That work, now I have to decide what I want to work with. Okay? So there's two pieces of information given. We have 24 grams. I apologize for that break on the line, so let's do this. Sodium hydroxide and liters of solution, right? Which of those two pieces of information do I want to work with? You want to work 24 grams. Why? Okay, so you want to work with grams of sodium hydroxide because you can convert it to moles. I can also convert grams into kilograms. I can convert grams into pounds. Okay. Do I need moles of potatoes?
I know. Moles of sodium.
It's not that I can convert grams into moles, because I can convert grams of oxygen into moles of oxygen. That's fantastic. Irrelevant. Okay. What is relevant is that I can convert grams of sodium hydroxide into moles of sodium hydroxide. That given piece of information is a substance. Where do I want my substance to appear in my final answer? In the numerator. Which means, where should that given piece of information, if that's what I'm deciding to work with first, appear in my work? In the numerator. Okay? That was a given piece of information. So I would argue that that should be over 1. Okay? Can you combine conversions? Yes, but again, the idea is to keep things as compartmentalized as possible. When you start crossing compartments, you can increase the odds of making mistakes. Okay? And walking around, I saw 2 people with correct full answers. Both of them did not compartmentalize the way I did. One got the answer right, one got the answer wrong. 50% odds, not so good. Compartmentalize. Okay? Is grams of sodium hydroxide what I want for an answer? No. Is no unit in the denominator what I want for an answer? No. So there's 2 things wrong. I get to decide which of those 2 things I want to fix. And by I, you. What do you want to do? Grams to moles. Bad color choice. Where do I want the grams to appear? In the denominator. Why? So it can cancel out. What unit do I want to appear in the numerator? Okay. Fantastic. Okay. Now the question is, does that exist? Okay. Where does that information exist to relate grams and moles? That's on the periodic table. Sodium was 22.99. Oxygen was 16.00. Hydrogen is 1.01. We add that all up, and what do we get? 40 grams sodium hydroxide. 1 mole of sodium hydroxide. Where does the 40 show up in my conversion? Why in the denominator? In my work here, it shows up in the numerator. It's not showing up in the numerator or denominator. It's showing up next to grams. In my calculation, grams shows up in the denominator, which means the 40 needs to go into the denominator. What goes with moles? 1. That's established from that conversion factor. What happens? Grams of sodium hydroxides cancel, and what do I have? Moles of sodium hydroxide, where? In the numerator. Is that where I want it?
Yes.
Yeah, fantastic. 1 problem down. Do I have another problem I have to fix?
Yes.
What's that other problem? I need liters of solution in my final answer. Okay? Do I know anything about the liters of solution? Okay? We're told that it is 0.100 liters of solution. We are literally told what the value is for the liters of solution. Where should it appear in my conversion? Should show up in the denominator. Why? That's where I want it to appear in the answer. What's the number that needs to go with it? 0.100. Why is that going in the denominator? It's showing next to the liters. What goes in the numerator? 1. What I'm saying is that I need to divide by that as an answer, or that as a piece of information. I now have my final answer. All I got to do is multiply things out. 24 divided by 40 divided by 0.1. And we get what for an answer? Oh, just 6? 6. Okay, because we haven't talked about it in a while, let's go ahead and make life difficult, because it wasn't difficult enough. Would this be a correct answer for show your work? For show your work. So one suggestion, molarity is supposed to be capital M. I fully understand capital M is moles per liter. I don't expect you to do that. In fact, I would encourage more wholeheartedly that you do moles over liters. The abbreviation to capital M is a bad idea overall. So I don't object to that. 6 point, someone started to push it.
No. It would be 24 moles.
6.00 moles of sodium hydroxide per liter of sodium hydroxide because
Yeah. 3, 6.
sig figs. You go back up to the question, you were given 3 sig figs and 3 sig figs, your answer should have 3 sig figs. Okay? Questions?
Put aqueous in
No.
the liter.
I understand where you're going with aqueous. Oh, and I shouldn't have said sodium hydroxide down there. That should have been solution. Thank you for pointing that out. Okay. Phases, I'm not a big fan of as long as specifying them, as long as you know they're there. If you're having a problem where you're consistently messing up phases, then yeah, you should go through and show all the phases. Typically, it doesn't affect anything, so I don't worry about it. Okay? Are there other solves to this? Yeah. Can I erase everything? Yes. Common solve that I'll see is that molarity equals mass. Sorry. Shows how well I do it. Moles over volume. Okay, I'm not given moles, so I'm going to take 24.0 grams of sodium hydroxide, convert that into moles. Grams of sodium hydroxide, moles of sodium hydroxide. And I'm writing 24. What was it, 40?
Yeah.
40 grams is 1 mole. I now have the moles of sodium hydroxide. The volume needs to be in liters. Oh, I was given that. 0.100 liters of solution. Because I know this formula, I can now take whatever that number was. Somebody did it. 0.6 moles of sodium hydroxide divided by 0.100 liters of solution, and I would get the answer of 6 moles per liter. Yeah? Okay. There's nothing inherently wrong with that calculation. But where that calculation hinged was right here. You had to know that formula. And then you said, well, I'm going to solve for those as independent pieces. Okay? The instant you start splitting things apart into those independent pieces increases the amount of times that you have to rewrite information. You are not a computer, and even computers fail at this. Okay? Rewriting the same thing over and over and over again, you will find you'll make mistakes. Particularly, you'll make mistakes when in a high-stress system. You're like, well, I never make mistakes in the homework. I know, because it's not a high-stress system. But the exam, on the other hand, is. And now what happens is when you go through to rewrite those numbers, is you start rewriting the numbers of other questions into it, or other things within your calculator, and you get your answer way wrong. Do not discount the stress factor. Make sense? New question. How many grams of potassium dichromate are in 125 milliliters of 0.150 molar potassium dichromate? Okay, this is, oof, is a common response. Oh, that's so much harder. Nothing about this question is any harder than what you just did. It's the exact same process. If you aren't following a process, this becomes a lot harder because what has now happened? You have to do a whole bunch more conversions that you have split out as individual steps as opposed to looking at the whole process. When you have the whole process, straightforward, it runs the same as any other process. So, in this talk through, I cannot again stress the process enough. Okay? And it's awesome that we've got this process and that we've got someone that's brave enough to write their solves up on the boards. Because in what I was about to write on the screen is actually written up on the board already, okay, which is fantastic. Wrong. Okay? So, step one, what is your goal? Okay? As I walk around, if the very first thing when you read a question isn't to immediately write equals, you're wrong. I don't care what you get for a final answer, you're wrong. Your entire process is out the window, you're making stuff up as you go. If you get the number right, it was blind freaking luck, you're not going to do well on the exam, period, full stop. Okay, that's where it is. Okay, so I wrote it too far to the left, so equals. What do I want? I want grams. And then in walking around, everybody was like, I want grams. I was like, of what? It's hard. So if you're asked that question, you're like, I don't know what that's called. That's fine. You could just spell it out. K2CR207. That's fine. There's no shame in that. I do it too. So maybe there is shame in it because I do it. Okay? So that's what we want for an answer. Okay? The question now is, what do we start with? Okay, so we have this 125 milliliters. We also have this 0.50 capital M. One of the things that's challenging with the English language is that there can be implied words within that we would need to grab a hold of. For instance, it's 125.0 milliliters of solution. And then that is 0.150 molarity K2CR207. Okay? And you're like, but it is written down there. Just because it's written down there doesn't mean you are cognitively going to uptake that, and that subtle technological effect there is that you get the question wrong or misinterpret it. Okay? That sucks. It's also not a whole lot we can do about it. Okay? I do proofread the exam and try to prevent that kind of, it's known as widowing, prevent that widowing effect, because I don't want you getting it wrong because of the technology of the exam. I want you getting it wrong because you don't know what you're doing. Make sense? Okay. So, milliliters of solution is relatively straightforward. Capital M isn't so straightforward. What is capital M? It is molarity. It is moles over liters. Okay? That needs to get written in. Let's take a look at the boards, or in particular the board to my left, your right. We did check that. And the person that decided to start that calculation started with 0.150, which is sort of okay.
Technically, I started over here, just for the record.
At this stage, they started with 0.150 what? Moles K2CR207. Where does the question say 0.150 moles of K2CR207? It doesn't. What it says is 0.150 moles of K2CR207 per 1 liter of solution. Like, well, but that as a number is just one that doesn't change the calculation. Right? Dividing by 1 doesn't change anything. You're right, it doesn't. But the placement of that unit, that changes a lot. That takes your answer from being correct to entirely wrong. Okay? Let's go through and start it out. So, moles of K2Cr2O7 isn't grams of K2Cr2O7, okay? But it is the same substance. So since the substance is showing up in the numerator, where should my unit or my substance show up in the work? Numerator. So I'll put K2Cr2O7. Yeah. Moles, liters of solution. 0.150 liters of solution, right? Numerically, nothing is different about our calculations. Okay, is moles the same thing as grams? No. Okay, so if they aren't the same thing, what do I need to do? I need to convert. I want to get rid of moles, K2Cr2O7, grams, K2Cr2O7. Where's that conversion factor found? Periodic table. I'm not going to show the math. Neither did you. Useful. What was the number? 294?
295.20.
Okay. The 294.2 moles. Yes? Okay. How valuable is the liters of solution right now? We just placed liters of solution. How valuable is that unit right now? You're saying not at all. So if it's not at all, let's just delete it. What would your units be after running this single calculation? Grams of potassium dichromate. Is that what happened on the board? No. And the people that I saw make this mistake didn't stop here either. They continued on. Why? Well, we were given a volume, so I got to use it. Maybe. You should use it if it's necessary to use it. If you were actually given 0.15 moles potassium dichromate, I don't give a crap about the volume. I have the answer. It's done. Is the unit actually valuable? Yes. This doesn't even have to do with the fact of how the number changes. This is just saying, I'm going to stop my calculation because I have the unit right now. You don't. Okay, so now let's add in that next layer. Okay, and actually I'm going to keep that erased for the moment. Okay, because the value of what was written on the board was that I know I have to use this volume, so I'm going to use this volume. Okay, volume, molarity. Where does volume show up in molarity? In the bottom. It shows up in the denominator, which means that I'm going to have to bring in my volume and place it where? In the denominator, because where does volume show up? In the denominator. So I'm going to put it in the denominator. 125.0 milliliters of solution. And I remember Mike said I can just place 1 in the numerator because that's a single contained value I just want to divide. Cool. You did remember something I said. That's good. I don't mean that to sound insulting. That's good. Okay? Is milliliters of solution what you want for an answer? No. So what has to happen? I have to get rid of the milliliters of solution. So I'm going to convert that into milliliters into liters because molarity is liters, right? It makes sense. That conversion. 1 milliliter is 10 to the negative 3 liters. Milliliters cancel. And let's take a look at what happened with the calculation where Greg is now standing in front of it. There's a giant arrow pointing at that little blank space saying something else needs to happen. What's that something else needs to happen?
Liters of solution.
Work. What the hell? I've got liters of solution and it needs to disappear somehow. I have no idea where it went. Where it went was at the very beginning of your calculation. You fudged the calculation and just hoped it worked. And it did not. Don't fudge your calculations. This is why inputting a single value compartmentalized value is incredibly important. Okay? That if you start combining things, you can make mistakes like this. Okay? So that means all of that volume calculation was actually done incorrectly. So let's go back and look at our work. What we were given is 0.15 moles per liter of solution. Do I want liters in the answer? No. So what do I know has to happen? Liters has to cancel. Was I given liters? No. Which means I'm going to have to convert liters into what? Why milliliters and not kiloliters? Because I read through the question and the question gives me context of milliliters. What you're doing is predicting one move ahead. What is that conversion factor? 10 to the negative 3 liters is 1 milliliter. What happens to your liters of solution? They cancel. We'd have milliliters of solution. Do I want milliliters of solution? What needs to happen? Milliliters of solution goes in. 125.0 milliliters of solution over 1. Now I can go through and solve. Okay? So for those of you who are like, I didn't know how to input it. You probably didn't know how to input it into your calculation. For what reason? There were so many conversion steps and long units that what ended up happening is your calculation carried across the whole page, and now you couldn't figure out how to place it in there because your calculation carried across the full page. Okay? Technology. The paper inhibited your ability to solve. Okay? So if you got to break it up, you got to break it up. Okay? I can understand breaking it up for that reason. Okay? What's an easy way to fix that?
Multiply by 125.
Turn the paper. You get a lot more space. You get 4 more inches of space. Okay? And that can help you do the solve. Okay? When are you going to see a multiple step conversion? I think I heard you say it. No, you didn't?
I said every question of the time.
No. I appreciate your opinion of me. That's a little nasty, but that's okay. It only shows up in the show your work. Where you're expected to do long conversions is in the show your work, which means when you go through to do your show your work, what should you do? Pull out the scratch paper, turn it on its side, and do your work there. And then write in the show your work section, look at scratch paper, because if you don't write that, all I'm going to see is blank space and be like, you have no idea what the answer is. Wrong. Tell me where your work is, for the record. Okay? Or cram it in there. I'm fine with it. Okay? I did also here, let's multiply by 0.125.
I said that, my bad.
Oh, you're bad. Why is that bad?
I don't, because you made a face. Because you made a face.
Why would I have made a face at 0.125? Where in this question is 0.125 given?
But it's 0.25 liters.
Where is 0.125 given in the question? It is not in the, what was that, Hatan?
Put that on the denominator.
It was not in the question. By converting the 125 to 0.125 liters, you've done a conversion in your head. Did you do it right?
Yes.
Yes. All you're going to get is a frowny face from me. Okay? Because your conversion is right. Do it wrong, you're going to get a frowny face, and you're going to miss a lot of points. And you might even get a, see, I told you so. Okay? That's the intent of the process, is to guarantee correct answers. That's why we follow it. It minimizes mistakes. That's it. Minimize mistakes. That's all I want you to do. Okay? Kind of makes sense? Okay. Before we step on break and I answer Christian's question, What you're looking at in this question is where molarity is used. A chemist needs to determine the concentration of a solution of nitric acid. One way to do it, they throw it on their partner and they see if they melt. Whoops, it was too high. That doesn't work well. That becomes a legal issue. You can't do that, at least not anymore. Okay? It also doesn't quantify the concentration. It just means like, yep, it killed someone. That's not a good way to do science. Okay? She puts 400, that's 400, a volume of acid in a flask with an indicator. She runs this reaction, all of this data. And then what the question is, what's the molarity of the nitric acid? You have to be able to process all of that information to come out with a single answer at the end. This question involves all of molarity. Okay? It involves all of equations, chapter 9. It involves moles, chapter 8. And you have to fold it all together into one giant mess of a question. How often are you expected to do this question? I would actually argue that this question is beyond the level of the lecture. Lecture, you do it in lab in 2 weeks. Okay? That happens in lab. But just like in lab, guess what happens? We walk through it. Okay? So what you should go through and do with a question like this, okay, ignore the teams, it's not extra credit, okay, is develop the process to solve the question. This is a long, remember, we had a page, type 12 font that filled the entire screen for miles to inches, or inches to miles. This is a lot more calculations than that. So you should develop a process to solve this question. Because if you understand the process to solve this, you understand the process to solve the question that was screwed up on the board over here. You understand the process for the first molarity question. You understand the process for Avogadro's number usage. You understand the process for this entire unit. It's easy. You just redo that process. Okay? So I highly encourage you to do that. If you choose not to, that is your choice. You will likely suffer for it on the exam. Okay? So you should develop a process. One of the things that you should be able to do, you got friends, pass it to a friend. Make them solve using your process. Can they get the correct answer? If yes, then your process was pretty awesome. Okay? If no, then you need to tweak your process. Okay? We'll pick up with chapter 10 and gases next week. Okay? Next week, you are going to have next week on Tuesday, you get to have me, for those of you that have Tuesday lab, for like 8 hours.
What?
Because I'm going to give the English lecture, I'm giving the chemistry lecture, and then you get to hang out with me in lab.
And Thursday you'll have me doubled in.
And Thursday you get Greg for 2 English classes, and then you'll get a sub for lab, because I'm peacing out next week. Okay? So we'll be doing a lot with gases next week. You should read up on it.